Hi everyone, how are you? Today I'm going to discuss the inheritance in brief. I have already discussed inheritance in inheritance 1 previous lecture. I am giving you this in brief. So inheritance is a very important concept. All of you know about it, and it's a concept where we can define one class from the existing class. But always keep in mind that use inheritance in case of there is a relationship. See this is a relationship. That means cat animal is a relationship. Car vehicle is a relationship. So in this kind of thing, please use inheritance. Otherwise, uh, please don't use it because there is basically three kinds of uh, relation in real life. If we think that they are broadly classified, one is uses a relationship, next one has a relationship, and then the last one, this one is a relationship if we broadly classify. So has a relationship, you can think that computer or whatever computer mouse has a relationship. Or if you think that mm, uses a relationship, bike road uses a relationship. So whenever you are going to design your real life programming, then obviously you have to think about it. So that's why I'm telling you, whenever you are designing your own project, then please remember that what kind of relationship it is, and in that case, if there is any is a relationship, then use the inheritance concept. Hope you understand. Okay, this one is the syntax of inheritance. I have already told you that access control, three access controls are there: public, protected, private. Public can be inherited as well as it can be used outside of the class with just dot operator. And protected, it cannot be used outside of the class directly using just the dot, but it can be inherited. And private is it cannot be inherited, cannot be used outside of the class. And types of inheritance I am discussing: a single inheritance, multi-level inheritance, multiple inheritance, hierarchical inheritance, hybrid inheritance. So these are the diagram. Single inheritance, multiple level 2 parent class, that is more than one parent class, one child class. Hierarchical, this one parent class, multiple child class, multi-level, more than one level. And hybrid inheritance, we are getting this and this. Okay, so this is the example of single inheritance. You can see this, that public animal, we are just taking a single base class and a single derived class. Next, this is, I think you can understand, one class. The animal is derived in mammal class and the mammal is derived in cat. So this is animal to mammal, mammal to cat. Yes, multi-level inheritance. And this one, animal, mammal, and both of these are in cat. This is example of multiple, two parent class and one child class. It is more than one parent class, single child class. It's called the multiple inheritance. This one is not supported in Java. And this one, animal, dog, and cat also derived from animal. Yes, this is hierarchical inheritance. Uh, and yes, this one is, here we have class A. Class A is derived in class B, and class C also derived from class A. Class D is derived from class B and class C. You can see this picture. This one, yes. Class A from class A to B, class A to C, and D is from class B and from C. So you can see that if you think that A, B, D, if you just see it in this line, you can understand this is multi-level inheritance. If you only see that A, B, C, this is A, B, and C. This is hierarchical inheritance. And if you just see that B, C, and D, that time this is multiple inheritance. So we have multiple types of inheritance here, and this one is known as hybrid inheritance. So the advantage of inheritance is this one, reusability and readability, and makes us write less code as both the classes. Obviously, if you have already designed one class and you are trying to design another class using the previous one, obviously the less code will be written. And what is the limitation? Limitation is in case of inheritance, the base and derived class got tightly coupled. So we know that in case of software engineering, uh, high cohesion, low coupling, we know that this one is required. But here, both of this, that means the base and derived classes, got tightly coupled. And vestige of memory and compiler overhead. This is a very important point, that compiler overhead. Because every time whenever you are creating one object of a class A, derived class, say for example this one, if you are creating object of class D, that time you have to create the object of class B, class C, and class B is from class A and C is also from class A, so you have to create invoke the constructor of A, B, C, and then D. So this is a compiler overhead. Every time whenever creating the object of class D, that time the compiler have to think about that from where it is inherited. So first the object of its parent class will be created, then it will be. Next, see this question. Class P, private, I and whatever, we have a friend void F1, and in class D, we are inheriting the class P, and it has int j d1, the constructor, and now you are going to call, say F1 is called here, and you are going to call or you are going to access the private member of derived class. Run this code and you will get the error because the friend function is not able to be inherited. See this, publicly derived class or whatever, it is publicly protected, whatever. The constructor and destructor will not be inherited. Assignment operator will not be inherited. Friend function cannot be inherited, and you know that the private members are not able to be inherited. So remember this point, that which cannot be inherited: constructor, destructor, assignment operator, its friend, and private member cannot be inherited. Next, constructor in derived class. Derived class instantiation may invoke both the base class constructor as well as the derived class constructor. And you can see that if parameterized constructor is in base class, it explicit specification in derived class initialization section. In case of default constructor in base class, explicit specification is not mandatory. See, if we have default constructor in base class, whatever will be the constructor in derived class, either it may be the parameterized or default, that time explicit initialization for the base class constructor is optional. Okay, if you have base class constructor, base class constructor default, that time whatever will be the constructor in derived class, explicit initialization is not mandatory. But if we have parameterized constructor in derived class, that time explicit initialization of base class derived class is important. Okay, I am giving you, see this example. We have default constructor, and here we have default constructor. So whenever you are creating the object of base class, derived class, that time first the base class constructor will be invoked, and then the derived class constructor will be invoked. You can see this. Yes. And see here, no explicit initialization is needed. No explicit initialization is needed. In case of this example, as this is a multiple inheritance example, T1 and T2. So as it is first inherited, you are writing the T1 and then T2. It will be like first T1 constructor will be called, then T2, and then derived class constructor will be called. So it is associated in this way. Left. See this part. What will be the answer? Of course, I think you can understand. First, the P constructor will be called, then the constructor of D will be. See this example. Here we have parameterized constructor in base class and default constructor in derived class, but we need the explicit initialization. See here, the explicit initialization is needed. Okay. And see also this example where explicit initialization is needed. It is derived parameterized constructed in base class, parameterized constructed in derived class. Again, explicit initialization is needed. So if we have a parameterized constructed in base class, that time explicit initialization is mandatory, whether it is whether it is parameterized constructed in derived class or default constructed in derived class. Hope you understand. If you have any question, you can ask me.